Dear students, we are on the CEC Gurukul lectures. We are in the series of the electronic circuits where we are defining the various electronics components which are used in designing of the electronic circuit. So in today's lecture we are discussing the amplifier which amplifies the signal, which amplifies the amplitude signal, low amplitude signal into the high output signal. So we discussed the various type of the amplifier. Now we discuss the next amplifier, which is the most commonly used amplifier in the laboratories as well as in the daily life, which is the operational amplifier. This operational amplifier is known as the op-amp and have developed from the circuits designed for early analog computers where they are used for the mathematical operations such as adding and subtracting. So this type of operational amplifier, that is the op-amp, used in the computers. Then the many circuits just for the mathematical calculations. So this is very important type of the amplifier. So today we are using widely use of this amplifier as in the integrated circuit, from where they are available in a single or multiple amplifier and packages, and often incorporated into complex integrated circuit for the specific application. So op-amps generally used in many circuits. The design is based on the differential amplifier, which has a 2 input instead of the 1. In this type of amplifier we have the 2 inputs or 1 output and produces an output that is proportional to the difference between the 2 input. So this is the basic type of amplifier. Without negative feedback, op-amp have an extremely high gain, typically in the hundreds of thousands. So its gain is very high, so generally used in the many electronic circuits. Applying negative feedback increases the op-amp's bandwidth, so they can operate as a wide band amplifier with the range of up to the megahertz. But it reduces gain also. So its bandwidth is in the megahertz range, but its gain is less as because of the wide range. A simple resistor network can apply such feedback extremely, and other extremely networks can vary the function of the op-amp amplifier. So this is a diagram of the op-amp amplifier. You see here is two type of the input. One is inverting input and second is the non-inverting input. Voltage positive and negative, and the output, one output. This is a symbol of the op-amp. Now amplifier parameters, which are generally used just to get the output of the amplifier. So what are the parameters? One is the gain, second is the frequency response, third is the bandwidth, input impedance, output impedance, phase shift and feedback. Some of the common definitions we have already discussed, that what is the gain, what is the frequency response. Now one by one we will see how we can adjust, how we can get the amplifier parameters. Now what is the amplifier gain? Amplifier gain which gives the output signal, which gives the relation between the input and the output signal. So the amplifier gain can be said to be the relationship that exists between the signal measured at the output with the signal measured at the input. And gain is defined as the output signal divided by the input signal. So amplifier gain, there are the 3 different kinds of the amplifier gain, which can be measured as a voltage gain, as a current gain and the power gain, which depending upon the quantity being measured, with example of these different of the gains given below. Now this is the amplifier gain of the input signal. You see here left hand side we are having a small input signal, and current is I in, V in is the voltage, gain is the output divided by input. Amplification stage here which increase the gain, and I output here we get, and the larger output signal we get from this amplifier gain of the input signal. So voltage amplifier defined by the voltage amplifier AV is equal to output voltage divided by the input voltage, that is a V out divided by V in. And similarly here, current amplifier gain, current AI is equal to output current divided by input current, I output divided by in. Power amplifier gain, that is defined AP is equal to AV into AI, multiplication of both the power, voltage and current. Power gain, you can divide the power gain obtained at the output with the power obtained at the input. Also calculating the gain of an amplifier and subscript of VI and P and used to denote type of the signal gain being used. So power gain or the power level of the amplifier can be expressed as decibels, that will be defined by the dB. Bell is a logarithmic unit base of the 10, so measurement of the no units. So bell is too large to unit measurement, it is prefix, and deci means decibels, instead 1 decibel being 1/10 of bell. So to calculate the gain of the amplifier in the decibel or the min, we can use the following expression. This is the just to get in the decibel. So output can be the gain defined in the decibel. The voltage gain is dB is equal to AV 20 into log of AV. Current gain is dB is equal to AI is equal to 20 into log AI. And power gain is in the dB is equal to AP is equal to 10 into log PI. So DC power gain of the amplifier is equal to the 10 times of the common log of the output to the input ratio, where the voltage and the current gain are 20 times the common log of the ratio. So that will be the 20 dB, not the twice much power of the 10 dB because of the log scale. So next is the frequency response. The amplifier parameters is also the frequency. So amplifier do not have the same gain at all the frequencies. If the frequency change, the gain will be the different. For example, an amplifier defined on the audio frequency application will amplify the signal with the frequency less than of the 20 kilohertz, but not amplify signal having the higher frequency. So in this above the 100 kilohertz will not amplify the lower frequency audio signal. So amplifier designed for the radio signal will amplify a band frequency above and about the 100 kilohertz and not more than that, and not amplify the lower frequency audio signal. So in each case the amplifier has a particular frequency response, and being the band of frequency where it provides the accurate amplification and excluding the frequency above and below this band where the amplification is less than adequate. So the frequency will define by this. You see here in the diagram that the voltage gain and here is the frequency. So the upper curve will define as a mid band frequency. This is the range of the frequency that is defined by 10 to more than 100 kilohertz. So this is the maximum gain, which is 0.707 of the maximum gain. So that is the medium gain. Now next parameter is the bandwidth, which is the important parameter, and which the important piece of information that can be obtained from the frequency response curve or is the bandwidth of the amplifier. You see here in this diagram the range defined as the frequency range define the bandwidth, how much bandwidth it is having. The frequency gives a bandwidth. The information we can get from the frequency response. This refers to the band of the frequency for which the amplified by its useful gain. Outside this useful gain of the amplifier is considered to be insufficient compared to that of the gain of the bandwidth. So bandwidth specified for voltage amplifier is the range of the frequency for which the amplifier's gain is greater than that of the 0.707 of the maximum gain. Like this we can define the maximum gain, which is define the bandwidth in the frequency curve. You see in the diagram that is a central mid-band frequency at the middle, and you see the 2 points has been taken, maximum gain is defined there. The 2 point has been taken and then just plot a straight line there, and then we can get the band width. This frequency range that will be defined by the arrow. This is the frequency range. What is the input impedance? The input impedance, the next parameter is the input impedance, which means opposition to the AC current flow. So at 0 hertz, that is the TC, impedance symbol is represented by Z and is the same as the resistance R, but the frequency other than 0 hertz, impedance and the resistance are not the same in the input impedance. So input impedance of amplifier is effective impedance between the input terminals. The effective here we use for the impedance means that of the amplifier components like resistor, capacitor connected across the input terminal. That's why it is affected. The impedance experienced as the amount of current able to flow into the input terminal for the given signal voltage applied to the particular frequency. If we are giving a particular frequency, then the impedance depends upon the current which is flow inside the input terminal, and that will be the input impedance is influenced by the number of the factors, including that of the frequencies applied to the signal, gain of the amplifier, feedback used, and even what is connected to the output of the amplifier. So input impedance parameter will depend upon what type of signal we are giving, what type of the gain we are getting, and how the feedback of the output signal. And what is the output impedance? Output impedance is an amplifier that not solely depend upon the actual component connected within the output of the amplifier, but it is an apparent impedance that can best the demonstration using the responsibility full of the signal voltage at output terminal of the amplifier. Output that impedance we can get the output terminal when a current is drawn from the output impedance. So more current drawn from the output terminal, the greater and reduce the output signal. In case of the output impedance, more current drawn from the output terminal, the greater reduction of the output signal voltage, and this effect that an impedance of the resistance in the series with the output terminal. So here on the screen, here we are having a input and output impedance. You see that left hand side, it is a input terminal which is represented by Z in, and the output terminal represented by Z out. Amplifier is here, input impedance in the parallel with the input, and the output impedance in the series with the output. That the box is represent the amplifier, that is represent for the input and output impedance, and that will be the output. So in this manner, these parameters can be adjusted, can be taken. So next parameter is the phase shift. Phase shift is an amplifier. Amplifier is the amount by which the output signal is delayed or advanced in the phase with respect to the input signal expressed in the degrees. Here the name suggests phase shift, how much delay in the signal output as compared to the input signal. So the phase of the 90 degree occurs when the peak of the output wave occurs 1/4 of the cycle after the peak of the input wave. So such shift cause the effect of the components such as resistor, inductors and capacitor in the amplifier circuit. So action of the transistor in the single stage amplifier can cause 180 degree of the phase shift, and that is also important sometimes to get the trigger. So the action of the transistor in a single stage amplifier can cause 180 degree of the phase shift, and therefore the input and output will be the anti-phase. If its difference is 180 degree, so the difference will be the 180, and they must be on the anti-phase. Whether the phase shift is amplifier important depends upon the purpose of the amplifier. You see on the screen here that this is the 90 phase shift left hand side, input and output signal, 180 phase shift. You can see that is a anti-phase, means 180 degree anti-phase phase signal change common in the amplifier. And the last one, phase shift, is defined as a 180 phase shift caused by the transistor action in each stage of the 3-stage amplifier. If we are using the 3-stage amplifier, you can see the 180 phase in 3 of the output. So this is the phase shift parameter. The design of the multi-stage amplifier must take the phase shift into the consideration. If we design a multi-stage amplifier, then we use the phase shift type of amplification parameter will be considered. The phase shift vary with the frequency. It is possible that is the same frequency that of the total phase shift may add to the 360 degree angle. The output signal of such a system allowed to re-enter into the input, then like we are giving the feedback now. So positive feedback occurs and the amplifier will become unstable and likely to oscillates in this case. Now next parameter, which is the feedback. So feedback is very important in this case. If we take the output on the basis of the feedback, so feedback is a process of taking a proportion of a amplifier's output signal and feeding back into the input signal. So the feedback can arrange to either increase or decrease the input signal. So that will be taken from the output. When the feedback is used to increase the input signal, it is called the positive feedback, and when the effect of feedback reduces the input signal, that will be the negative feedback. So two type of feedback we will take, positive or negative. Positive means small, positive means high input we will take, and negative we are taking we reduce the input signal. Positive feedback occurs when the feedback signal is in the phase with the input signal, and this increases the amplitude of the input, hence the output signal. Effectively increases the gain of the amplifier. So in the positive feedback, the phase will be the same, and so that the input signal will increase and the output will be take. Now negative feedback occurs when the feedback signal is in the anti-phase and the input signal effectively reducing the amplitude of the input and hence also the output signal, and this is causes the reduction in the gain. In the high quality amplification, the negative feedback is often used to reduce the gain of the amplifier, and the benefit of this type of distortion signals, background noise produced in the amplifiers, is also reduced in case of the output signal. Another importance of the negative feedback increases the bandwidth of the amplifier. So here on the screen we are having the negative feedback, which reduces the gain, distortion and noise. It also increases the bandwidth. You see on the left hand side here we are having the anti-phase feedback added to the input signal, reduces the input, and you see here, and it is also in the phase, so the input signal will increase. So the portion of the output signal fed back to the input, and then the output is the reduction in the input signal leads to the reduced output. Now you see here, that is the bandwidth, reducing the height of the gain curve, produced wider spacing of the 0.070 point, therefore widening the band width in this case. Sometimes it will be the important. And you see the voltage amplifier characteristics for the ideal and practically. The any value of the voltage gain can be infinite if needed, and infinite input impedance and zero output impedance in case of the voltage, in case of the ideal amplifier. But as a practical amplifier, certain value of the gain cannot reach infinity, and the high input impedance and low output impedance, that will be defined in the voltage amplifier. What are the type of power amplifier. Power amplifier where the power of the signal will increase. So how many types of the power amplifier? The most well known type of amplifier which are not the power amplifier which have classified on the basis of the proportion of the input cycle during which the amplifier is given an output. So proportion of the active input cycle which is given to the power amplifier is known as the conduction angle. So for example, 360-degree conduction angle means input power means that the device is always on, and the conduction angle of the 180 means that the device is only for half of each cycle, but for the 360 on for the full cycle, but here 180 half for the each cycle. And now the different types of the power amplifier we have is the op-amp. Op-amp is the, here we see, you see on the screen that this is the op-amp diagram and it is represented by this, and op-amp is the amplifier or the buffers in general are drawn as a triangle in the circuit. Schematically we can see here there are two type of the input it is having, one is the inverting and second is the non-inverting, and the one output it is having. So it is defined by the number here. You see 2, 3, 4, 5, 4, 6, 7 here, inverting input and with the non-inverting input, diode on the pin 1 end. So op-amp also define the power connection, that will define here. Note and the ideal op-amp which is the infinite voltage, having the infinite voltage gain, a voltage difference at the two input is magnified indefinitely. So sometimes it like the positive means it is having a positive and negative terminals which is amplified up to the 20,000 or 2 lakh sometimes something. The ideal op-amp, infinite input impedance, no current flows into the input into basically we use the FET input of the op-amp. So here we have discussed the amplifiers. Amplifier which amplifies the signals, and the amplifier defined on the basis of its parameters and on the basis of its utility. So in the next lecture we continue its applications. Thank you.